Second step is to ignite their minds with the spirit of conceptualization. See, there is an apple, or the proverbial apple falling to the ground. Newton, observing it at his farm in the Lincolnshire, is said to have got the idea of gravitation here. Oh, that's a binary star. How beautiful is that? Both the stars are faithful to each other. Shall we surf the tidal waves? Once again, the reason must be gravity. Watching these seemingly disparate phenomena reveals the concept of gravitational force. Once these visuals are shown, there is no need for the teachers to do acrobatics in the classroom, saying that apple is falling to the ground, or earth is going round the sun, or there are tides rising and falling. The best thing at Delta is we can beam these visuals to all classes simultaneously. The third stage is making the students thorough with formulation. And the fourth stage of what edicts does in doing science is improving their manipulation skills. Edicts gives us the trick of creating hundreds of hours to improve these two qualities of formulation and manipulation. This is made possible here at Delta by judicious use of technology by the experts. One more important question I would like to answer is, how do we remove tension from a child's mind? This should be tackled on both the fronts, curricular and extracurricular. In the classrooms, lessons should be stimulating and should be stretching the students' imagination. Here is a video on the principle of conservation of linear momentum in a closed system. Let us feel the excitement in a gravity-free space.
Conservation of momentum tells us that the total momentum in any closed system will remain the same all the time. And since momentum is equal to mass times velocity, even if you have multiple objects going at different speeds that might collide, for example, the total momentum of the system before and after the collision will remain constant. So for example, these two balls, which in this case happen to be of equal mass, whether one of them is moving and causes the other to move, or they're both moving and collide and move off in different directions.
The child will now go to a different world where he feels there's no gravity, so the bodies will be floating, and he'll be dreaming that he is there in the spaceship and he's experimenting with the conservation of linear momentum. Once you take the children to that world of imagination, whatever pressure they were experiencing while doing serious maths, physics, chemistry would have gone, and reality, they'd start looking at serious things now. Momentum before collision is momentum after collision, when there are no external forces at all. Having no external forces, how could you create, how could you show in a real-time situation here? It's not possible. But now a student at once should have understood what a closed system is, and how can you remove the forces, and how can you understand the principle of conservation of linear momentum. Now learning becomes an experience, or the feeling keeps lingering after the class.